Good day, everyone. So, today we will be discussing the chapter 7, the nature of geometry. So, before we start, under the geometry, there will be an introduction and transformation, renaming transformations, translations, reflections, rotations, deletion of enlargement, perimeter and areas, and last is polygons. So, before we start, let's have a quick introduction about geometry. What is geometry? Geometry is defined as a branch of mathematics that deals with the measurement, properties, and relationship of points, lines, angles, surfaces, and solids. Put even more simply, geometry is a type of math that deals with points, lines, shapes, and surfaces. So, where is the origin of geometry? The word geometry is derived from an ancient Greek word geometron. The word geo means earth and metron means measurement. The study of geometry is extremely ancient and has been carried for many thousands of years across all civilizations, from Egypt, Babylonia, India, China, Greece, and the Incas, and so on and so forth. So, what is the purpose of geometry? Geometry is important in daily life because it helps with spatial understanding, measurements, and problem solvings. It enables us to navigate our surroundings, plan and design spaces, and make accurate calculations for various practical tasks. So, what is the importance of geometry? Studying geometry provides the students with many foundation skills and helps them to build their logical thinking skills, deductive reasoning, analytical reasoning, and problem solving skills, thus contributing to their holistic development. And lastly, how is geometry used in real life? Some of the common applications include measurement of a line and surface area of a land, wrapping gifts, filling of a box, or tiffin without overflow. Shapes used for different signboards. A person with good practical knowledge of geometry can help himself to measure the dimensions of a land without a chance of conflict.
I'm Queenie Ordonio Macaburas and I will discuss transformation geometry. So, transformations means to change, right? Hence, a geometric transformation would mean to make some changes in any given geometric shapes. So, here's the different types of transformations. Based on how we change a given image, there are five main transformations. First is a translation. Happens when we move the image without changing anything in it. Hence, the shape, size, and orientation remain the same. For example, in this figure, the blue one is doesn't change but change in direction, as you can see here in color orange and color red. It's just moved from the other side. Next is the rotation. Is when we rotate the image by a certain degree. For example, on rotation of the blue image by 90 degrees, we get the red image. As you can see here, when the blue image rotates in 90 degrees or half, 90 degrees, half, the shape forms as like that. Next, reflection is when we flip the image along in a line, the mirror line. The flip image is called the mirror image. As you can see in this video, the figure is forms like this and mirror to the other side, but the size is remain the same. Next is deletion. Dilation is when the size of an image is increased or decreased without changing its shapes. As you can see in this figure, the shapes remains this shape, but the figure shows that this figure increases. Increases? Decrease? Increase. So lastly, the reflection types of reflection is the glide reflection. Is when the final image which we get from reflection is translated. So there is a combination in it from the reflection to and translated. For example, in this figure, as you can see, the figure mirrored and moved to other direction. That is the combination of reflection and translated in glide reflection. And that's all on this video.
Our next topic is going to be translations. So what is translations? Translations occur when a figure is moved from one location to another without changing its size, shape, or orientation. It slides an object a fixed distance in a given direction. In easier words, it's saying na you're going to move a shape or an object in a um, designated place, indicating how many units you're going to move it to the left or right or up or down. Here is an example of a translated object. This encircled object is the one that is translated, and this one up right here is the result of the translated object. So it says here that we shall move it 4 units to the right and 8 units up. Kapag gagawin po ito, we should start sa letter E. Sinabing 4 units to the right, so we are going to count. From here, we will start here. So we are going to count 1, 2, 2, 3, and 4. And kapag sinabing 8 units up, kung saan ka nag-stop sa 4, doon ka naman mag-start sa number 1. So 1, 2, 3, 4, 5, 6, 7, 8. So it ends there. For the next, you're just going to repeat it on the other letters. Ayun, magre-result siya ng ganito. All of them are 4 units to the right. So pag D, 1, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. Kapag F, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Ganon din sa G ang nangyari, kaya naman, naging ganito yung result. The shape will not change, or the shape will not change, pero yung placement niya, dun lang ang magbabago kasi yun yung mismong tina-translate natin.
Hello everyone, this is Lara and Sana, and today I will be discussing what is reflection. So first, let us define what is reflection. Reflection is a type of geometrical transformation where an object is flipped to create a mirror or congruent image. Meaning, your reflection, it occurs when you flip an object and it doesn't change the size or the shape. Meaning nun, it is just perpendicular dun sa pre-image. Then under the reflection, we have two types, the line reflection and the reflection point. So now, let us discuss what is line image. So, an image is said to be line reflection if it will reflect through a line. So, ganito po siya nag-work. First, let's say for example, you will draw here. And also here. Ayan. So the distance from the point to the line of reflection is the same as the distance from the point's image to the line. So meaning magkakaroon ng imagery line dito. Pareho sila ng distance sa isa't isa and pareho din sila ng point's image dito sa line na create natin. So, after discussing the line image, or the line reflection, let us now discuss the reflection point. So, reflection point occurs when a figure is constructed around a single point known as the point of reflection or the center of the figure. So, gagawin natin siya ngayon. Let's say, for example, this is the y-axis, then line. Sorry if it is not straight line, then this is the x-axis. So, ang sabi dito, occurs when a figure is constructed around a single point known as the reflection point or yung center of the figure. So, this one, magdodraw tayo dito. And another image here. Ayan. So, paano mo malalaman kapag magkocross siya dito? Ayan, ito yung center na tinatawag dito sa point of reflection, ay dito sa reflection of point. Kailangan magkocross siya dito sa center or yung point of reflection na center ng figure. However, there are also different types pa ng reflection point. Wait. I am just going to fold the paper. Ito. Let's draw again the y-axis and the x-axis. Ayan. So, we will draw here and also here. So, paano magiging, let's say na ito, nakapantay siya dito. I'm sorry kung hindi siya nakapantay here. Anyways, let's say na paano siya magiging reflection point kung mukha naman siyang line of reflection or line reflection. Again, wag malilito kasi ang sabi natin, if the figure crosses the point of reflection or yung center ng figure. So, this is the line na magko-cross dito. So, nag-cross ulit siya doon sa center ng figure natin, which is etong nandito sa gitna ng x and y axis natin.
So now let's talk about the rotation. A rotation is a transformation that turns a figure about a fixed point called center of rotation. An object and its rotation are the same shape and size, but the figures may be turned in different directions. So here are some pictures where rotation is involved. To describe a rotation, we need to know three things. The first one is the angle of rotation. When we say 1/2 turn, it is equals to 180 degrees. When we say 1/4 turn, it is equals to 90 degrees. When we say 3/4 turns, it is equals to 270 degrees. The second one is the direction of rotation. It is either clockwise or anti-clockwise. Sometimes the direction of the rotation is not given. If this is the case, we use the following rules. A positive rotation is an anti-clockwise rotation, and a negative rotation is a clockwise rotation. The third one is the center of rotation. This is the fixed point about which an object moves. For example, a rotation of 60 degrees is an equals to an anti-clockwise rotation of 60 degrees. A rotation of negative 90 degrees is an equal of clockwise rotation of 90 degrees. Example number 1. Write the coordinates of vertices after a rotation 270 degrees counterclockwise around the origin. We know that a rotation turns a figure around a fixed point. In the problem, 270 degrees is equals to 3/4 of a full term. The rotation will turn the 3/4 square of a full turn in a counterclockwise direction. Take note that 270 degrees counterclockwise is the same as 90 degrees. Now, let's identify the current coordinates of each point. Point T has coordinates of 3, 0. Point U has coordinates of 3, 5. Point V has coordinates of 8, 5. And point W has coordinates of 8, 0. Now that we know the current coordinates, we will rotate them into 270 counterclockwise around the origin. The point T will have the coordinates of 0, negative 3. The point U, we're gonna have the coordinates of 5, negative 3. The point V, we're gonna have the coordinates of 5, negative 8. The point W will have the coordinates of 0, negative 8. Let's have another example. Find the coordinates of the vertices after a rotation of 180 degrees counterclockwise around the origin. 180 degrees is a 1/2 of a full turn. The rotation will turn the triangle. The rotation will turn the triangle 1/2 of a full turn in a counterclockwise direction. The current coordinates of point U is 0, 4. If we rotate it into 180 counterclockwise around the origin, the point will move from the positive y-axis to the negative y-axis. Now, the point U will have the coordinates of 0, negative 4. Next, the current coordinates of point V is 0, 9. If we rotate it into 180 counterclockwise around the origin, the point will move from the positive y-axis to the negative y-axis. Now, the point V will have the coordinates of 0, negative 9. The current coordinates of point W is negative 9, 4. If we rotate it into 180 counterclockwise around the origin, the point W will have the coordinates of 9, negative 4. The rotated points form of a triangle congruent to UVW will be shown. We have another example. Graph the image of rectangle RSTU after a rotation of 90 degrees clockwise around the origin. 90 degrees clockwise is the same as 270 degrees counterclockwise. We can apply the rule either 90 degree clockwise rotation or 270 degrees counterclockwise rotation. The current coordinates of point R is negative 9, negative 9. If we rotate it, the point R, we're gonna have the coordinates of negative 9, 9. The current coordinates of S is negative 6, negative 9. If we rotate it, the point S, we're gonna have the coordinates of negative 9, 6. The point T has the current coordinates of negative 6, negative 3. If we rotate it, the point T, we're gonna have the coordinates of negative 3, 6. And the point Q has the current coordinates of negative 9, negative 3. If we rotate it, the point Q, we're gonna have the coordinates of negative 3, 9.
Hi guys, so today I will be talking about the dilation and enlargement. Dilation or enlargement in mathematics. Dilation is a type of transformation in which the size of a shape or geometric figure is changed, but the relative proportions and shape remain the same. The pre-image and the image are always similar in shape and orientation. So, ang ibig sabihin lang nito is when we are talking about the dilation or enlargement, the size can be changed but not the figure itself. Below are some examples. Ngayon, makikita nyo ito, Etong malaki na to, pwede siyang lumiit ng ganito or vice versa. Katulad din naman ito. Tapos from image A, from pre-image, nagiging ganito siya. Lalaki, liliit, or liliit, lalaki. Now, the dilation and enlargement always depend on the scale factor. The scale factor, sometimes called the scalar factor, measures how much larger or smaller the image is. The scale factor is the ratio of image to its pre-image and the ratio of corresponding sides. Now, the dilation enlargement always depends on the scale factor, or also called as the scalar factor. It measures how much larger or smaller the image is. It is the ratio of the image to its pre-image and the ratio of its corresponding side. Ngayon, pag-usapan naman natin yung transformation rule. The transformation rule is, it states that the scalar factor na tinutukoy is the K. To siya. Now, K is always given. Always remember that if the value of K is less than 1 but greater than 0, ibig sabihin yan, reduction. For example, 1/4, 1/2, 3/4, and so on and so forth. Now, if the K naman is greater than 1, then 4, it is called the enlargement. Ngayon, meron tayo dito sa example number 1. Ang gagawin mo lang dito para makuha mo yung corner points or yung coordinates is i-multiply mo lahat sa K. Ngayon, sinabi ko kanina, the K is always given. Now, ang value ng K natin dito is 2. Ngayon, yung 2, i-multiply mo lang siya kay point G, which is 0 and negative 2, point H, 1 and 3, and point I, which is 4 and 1. Ngayon, multiply mo yung 2 kay point G, so we have 2 times 0 is 0. 2 times negative 2 is negative 4. 2 times 1 is 2. 2 times 3 is 6. 2 times 4 is 8. 2 times 1 is 2. Ngayon, pagtapos mo na siya i-multiply, ito yan. Ito yung kinalabasan niya. So, we have here the example number 2. Write the coordinates of the vertices after dilation with a scale factor of 1/4, centered at the origin. Now, since, like I said earlier, the scale factor is always given and it is 1/4, since it is less than 1, our dilation is a reduction. Ngayon, katulad ng sinabi ko kanina, para makuha mo yung corner points o yung dilated points, i-multiply mo lang yung scalar factor sa mga corner points. So, we have L is negative 8 and negative 4 multiplied by 1/4. Kalabasan niya is negative 2 and negative 1. And corner M is 8 and negative 4 multiplied by 1/4, ang kakalabasan niya is 2 and negative 1. And corner N, negative 8 and 8 multiplied by 1/4, kakalabasan niya is negative 2 and 2. Ngayon, kita nyo sa upper figure, mas malaki siya. Ngayon, since our dilation is reduction, mas liliit siya sa ganito. Ngayon, titignan natin bakit lumiit siya ng ganito. Since nakuha na natin yung mga value na iyan nahanap, igagraph na natin siya. So, sabi dito sa point L, negative 2 and negative 1. So, ito ang ating x-axis, ito ang ating y-axis. Ngayon, ito yung x, ito yung 1. Ang ating x is negative 2. So, bilang tayo, since it is negative, pa kaliwa. So, 1, 2, negative 1, pababa, negative 1. Kaya, nandyan ang ating point L. Sa point M naman, ang value na nakuha is 2 and negative 1. So, 1, 2, negative 1, pababa, 1. Kaya nandyan ang ating point M. Dito naman sa N, it's negative 2, 1, 2, and pataas since it is positive 1, 2. That's why nakuha natin itong figure na to. Again, mag-iiba lang ng size but the figure itself stays the same. Now, we have here another example. Write the coordinates of the vertices after dilation with a scale factor of 4 centered at the origin. Ngayon, since ang ating scale factor is 4, ang ating dilation is enlargement. Bakit? Kasi it is higher than 1. Ito yung ating coordinate point. Imumultiply lang natin like I said earlier. Ang corner Q is negative 1 and negative 1 multiplied by 4. It is negative 4 and negative 4. Tapos yung point R is 2 and negative 1 multiplied by 4 is 8 and negative 4. Ito namang point S, 2 and 2 multiplied by 4 is 8 and 8. Ito naman sa T, negative 1 and 2 multiplied by 4 is we have negative 4 and 8. Ngayon, makikita nyo dito sa figure 1 sa taas, maliit lang yung square, di ba? QRST. Ngayon, since ating dilation is enlargement, therefore, lalaki siya. Makita nyo siya pag nilagay na natin sa graph. Ito yung sagot natin sa Q, negative 4 and negative 4. So again, our x-axis and y-axis, first given is negative 4 and negative 4. 1, 2, 3, 4. Since negative 4, pababa. 1, 2, 3, 4. Ayan na yung ating point Q. Ngayon naman sa point R, it's 8 and negative 4. So, since positive, pakanan. 1, 2, 3, 4, 5, 6, 7, 8, and negative 4, pababa. 1, 2, 3, 4. Yan ang ating point R. Dito naman sa point S, 8 and 8. So, balik ulit tayo sa center point, bilang ng pataas sa 8 since it is positive. 1, 2, 3, 4, 5, 6, 7, 8. Pakanan since it is positive. 1, 2, 3, 4, 5, 6, 7, 8. Ayan nating point S. Ito naman sa point T, balik ulit sa center point, bilang ng pakaliwa since it is negative, negative 4. 1, 2, 3, 4, bilang ng 8 pataas since it is positive. 1, 2, 3, 4, 5, 6, 7, 8. Ayan na ating corner T or point T. So, Q, R, S, T, kung mapapansin nyo, lumaki kasi nga ang ating dilation is enlargement kasi ang ating scale factor is 4 which is higher than 1. And that is all of my report. Thank you.
So for chapter 7, I'm going to discuss perimeter and area. First is perimeter. Dito kinukuha yung total measurement outside ng isang shape o yung tinatawag na polygons. Ito yung two-dimensional figures na gawa sa straight line na nakakonect end to end. Isang example nito is kapag bumibili ng property, kinukuha yung perimeter para malaman yung total measurements ng property. Ang gagawin lang is kukunin yung measurement ng given polygon and imumultiply yun sa kung ilang sides ang meron sa polygon na yun. So, for example, since dalawang side ang may measurement na 5 cm, imumultiply lang siya by 2. And yung 10 cm din may 2 sides, so ganun din yung gagawin. So, i-add lang siya, bale. So, ito yung perimeter sa example na to. So, next naman is ang area. Kung sa perimeter, kinukuha yung total measurement outside ng two-dimensional figure. Dito naman sa area, kinukuha yung nasa loob. Yung measurement ng area is nakadepende sa klase ng figure na kukomputin. Sa rectangular figure, imumultiply yung base and height. So, for example, dito, area is equal to base times height. So, yung base is 10 cm multiplied by 4. So, naka-square kasi yung square is the standard unit in measuring area. Kaya kailangan yung final answer is laging naka-square. Okay, next naman is yung triangle. So, dito ang computation naman is area is equal to 1/2 base times height. So, isa-substitute lang siya. Ang area dito, 48 cm squared. Okay, next is yung square. So, since same lang yung height and base niya, ang computation is madali lang. Area is equal to so 10 times 10 lang, sabihin 100. Okay, next naman is parallelogram. So, dito, ang computation lang is base times height. So, dito sa example natin, isa-substitute lang siya. Ganun lang. And last is yung trapezoid. So, dito, ang computation is area is equal to 1/2 base 1 plus base 2 times height. So, dito ay sa-substitute lang siya. So, height na 40. Okay, so ang area sa example sa trapezoid is 4,400 centimeters squared.
Polygons. Two-dimensional figures can be classified by the number of sides a figure has. Closed figures with 3 or more sides are generally called polygons. For example, a hexagon is a polygon with 6 sides and a nonagon has 9 sides. So both hexagon and nonagon is a polygon. So here are some examples of figures. First is a rectangle has 4 sides, triangle has 3 sides, square has 4 sides, trapezoid has 4 sides, pentagon has 5 sides, parallelogram has 4 sides, hexagon has 6 sides and the right triangle has 3 sides. So all of that is called a polygon because all of these figures has 3 or more sides.